So I know because it's a quite early morning, especially in Indonesia. I don't know where are you from, guys. Let me know you better after this. But I know this is a morning class is always a critical time to have this kind of class. But I hope you are as excited as me to discuss just a little bit, and also let me share my experience on precision farming and towards sustainable agriculture. So this is a topic for today. Before we start to the materials, let me reintroduce again to myself. So yeah, again, you can call me Dali. So I have a passion always in life science and agriculture in or food production sector, especially. That's because I think I exposed to a lot of this topic from my university degree when I did my bachelor in bioengineering. That is why my thesis topic is more or less in food production sector. At that time, I think I'm researching about what I'm also doing now in bioengineering, that how water is flowing under the soil and then go to the plants. So starting from that, I think I still and until now I still have always a passion in agriculture. But then I think that to be able later I will have the topic about this one, but to be able to make this kind of solution in agriculture, we need a lot of information. We need a lot of experience on how to deliver this to smallholder farmers, because in Indonesia, 90% of the farmers are smallholder farmers. So that is why from that lack of information on that sector, I took a degree of master in science and business management in Utrecht University in the Netherlands. At that time, I did several research and also several thesis. I wrote several theses. The first one is a very scientific thesis in the molecular plant physiology of Utrecht University laboratory. And I was joining one of the project called Azola project. The topic is Azola towards bio-based economy, and my thesis, what is it? The thesis title is how to make Azola more digestible. If you know Azola, Azola is it's not a like a developed plant. It's actually a fern. It's a floating fern. We can also find it in Indonesia, but also it's also spreading all across the world and also in the Netherlands. And Azola is high in protein, so we believe that it can be the like more sustainable source of protein for cattle and also for other husbandries animals. But the problem is it has this kind of secondary metabolism that make it less digestible. So what I was researching is more about how to make it more digestible. And then in the second year, I also did a research in more like a business research, but again in bio-based industries called Total Corbion PLA. It is one of the biggest producers of polylactic acid, which is the bioplastics, and so it's bio-based plastic and also biodegradable plastic. And on that time, I learned on how to make this kind of product is more fit with the market, which is a very limited market at that time. But currently, the market for this kind of bioplastics is increasing. So at that time, I was researching on how to make this product more usable for a lot of the markets. So during my studies and also my professional time now in Biops Agrotechno, I'm always exposed by the topic of biorefinery, circular economy, bio-based industry, bio-based economy. So that is why I am so excited to be able to be one of the speaker on this class. And I'm really excited to meet you guys and have a discussion. So during my sharing, if you have question or if you have remarks or anything, just let me know. Just I don't know. I think you can just unmute and ask me question because I like to have more like a discussion instead of like a one way of lectures. So that's a little bit about me. So just a little bit of context. I would like to play a video of my company profile in Biops Agrotechno. So I also can introduce my company. Okay, so I always have this problem. So let me share the video to my um, this one. So let me share some. Please bear with me. Uh, Okay, so Biops Agrotechno is basically a startup company. So we are focusing on the developing solution for agriculture. But most of what we are doing is actually developing the technology-based solution. I will have the material about this, why technology and precision farming is really relatable later on the slide. But let me introduce you to Biops Agrotechno.
Hi, I'm Dali, a co-founder and CEO of Biops Agrotechno. Indonesian population is still growing and is most likely to continue increasing. This increase is directly proportional to the increase in food demand. If there is no improvement to the conventional agricultural system, it is difficult to meet the increasing demand of the food. On the other hand, the use of water in conventional agriculture is far from efficient, while the access to water is limited. Therefore, the use of water, especially in agriculture, should be more effective and efficient. Biops Agrotechno is present as a startup company in the field of agricultural technology that creates innovation, namely Encomotion, as a solution to agricultural problems in Indonesia. Encomotion is an IoT-based solution that allows us to do automatic and precise irrigation. The use of Encomotion can increase productivity and save water and nutrition usage by up to 40%, while reducing the operational cost by up to 50%. We do believe that implementation of technology in agriculture will bring the new era of agriculture in Indonesia and address the agricultural problems now and in the future.
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Wilarto, umur saya 47 tahun. Saya di sini sekaligus sebagai ketua kelompok tani. Saya mencoba membangun greenhouse untuk sedikit menerapkan teknologi pertanian yang mana di greenhouse insya Allah daya tanaman akan lebih baik. Nah, situ saya sering kekurangan air. Dengan air yang sedikit kita bisa bertani maksimal. Saya mencari di medsos rekomendasi apa yang bisa mengatasi permasalahan tersebut. Nah, di situ saya menemukan Biops Agrotech yang mana bisa memberikan suatu solusi untuk mengatasi permasalahan air tersebut. Di Biops, di sana dikembangkan salah satunya yaitu ada istilah siramot, yaitu siram otomatis. Nah, ini cocok dengan kendala yang saya hadapi. Namun saya juga sedikit ada kesusahan juga. Di Biops ternyata ada program sharing profit. Dari sini kita akan bekerja sama dengan PT Biops menerapkan program tersebut di GH saya. Saya berharap sistem profit sharing dari Biops ini dapat membantu lebih banyak lagi petani-petani di sekitar kami sehingga kami dapat sama-sama merasakan manfaat dari teknologi irigasi pintar Encomotion ini.
Okay, so yeah, from this video, I think that's basically the outline of my presentation or my sharing today. So I will dig into more details about what the information that you have seen on the video, starting from what's the problems actually that we seen in Indonesia and what we are developing actually, and until what is the challenge regarding about the economy and the business, the business aspect of this, and how we make it possible for a lot of us, all the farmers like Wilarto, to use our technology in Indonesia. But that's my context. So just so let me also know you guys better. So Okay, so for every one of you, please use your gadgets. You can use your laptops or even using your mobile phone to scan this QR code and go to the Mentimeters that I have prepared, where I have prepared some question for you guys. So please let me know on the chat if you have problem to go to this link. I also will copy this link to the chat so it's easier for you guys to join. Miss Lily, you're also please feel free to also join so we can have a discussion or like a warming up before we start the lecture. Okay. Please raise your hand if you have problem going to the link. Otherwise, I can also already start the Mentimeters. Can anyone let me know if you guys already in the Mentimeters page? Hello, is anyone here? I know it's still in the morning, but please be excited. Hello, guys. Miss Lily, is my voice audible?
It's very clear, Mr. Dali.
Okay. Okay. Yeah. Someone is already, a lot of people already here. Okay, so for the first question, one word about sustainable agriculture. So with this question, I would like to know what you guys are thinking before the lecture, what you guys thinking about the sustainable agriculture, because a lot of people have different view on this one. A lot of people also have cynical comments on sustainable agriculture, but let me know what you are thinking. There is no right or wrong answer. I just want to know what you're thinking, what we are thinking. Okay, so here all natural, green environmental tech, regeneration agriculture. That's very good. Better. Yeah, a lot of people believe that sustainable agriculture is the better way or the best way to do agriculture. Less waste. I love that. We will go into that during my presentation. We'll talk about the waste in agriculture. So it's good. Organic compost. That's one of the implementation, but we will talk about that later in if we have time, other time to discuss. But that's a right answer. Organic compost. Yeah. Perpetual. That's good. Productive, yes. A lot of people thinking that sustainable agriculture not resulting in more productive agriculture, but what I am believing is actually it must be more productive. There will be during my presentation there will be one of this case study that I will share to you that using the sustainable agriculture and more precise irrigation will have more or higher productivity. Ecosystems, of course, we always need to know about the ecosystem before doing anything. And yes, for the sustainable agriculture, we need to know about the ecosystem. Okay. So very good, guys. Thank you for the participation. This is what you're thinking about the sustainable agriculture. Let's see if you have another thinking after my sharing today. Okay, so now to the next one. Okay, wait a minute. Okay. Okay, can everyone see this question on your screen? The second question. Currently, we are going to the next question. What makes agricultural practice unsustainable? Go to the next slide and then answering again this question. What makes agricultural practice unsustainable for you? Okay, guys, have you seen the question? Okay, waste. It's what kind of waste? After this, I will ask someone to share. Waste, yeah, it can be unsustainable, but what kind of waste? A lot of waste that is produced by agricultural sector or food production sector. We will talk about this later. Also, the pollution. I think it's kind of in one way with the waste because a lot of agrochemicals also making pollution. We are talking about the soil, polluted soil, polluted water, and etc. Polluted what is it? The production of the fruits or the vegetables itself. The political issues, that's interesting. I want to know who is writing this one. Can you write on the chat on the Zoom who is writing political issue, and would you like to share with us what you are thinking about this one? While waiting, we have climate change. I think it's more like unsustainable agriculture makes some problem in climate change. But if you have if you think it's the other way around, just let me know also in the chat. Exploitation, good. Infertile soil, chemicals, yes. A lot of research have been done and showing that unfortunately in Indonesia a lot of agricultural land is polluted by the fertilizer or chemical fertilizers. Monoculture, it's interesting. Talking about the regenerative agriculture, we are also talking about the multiculture, or in Indonesia, from long way ago, we already know about the tumpang sari. It's the other way around compared to the monoculture. Profit over hygiene, that's good. We will talk about that later. Fertilizer, overgrazing, and yeah, very good. So that's about what makes the agricultural practice unsustainable, and that's based on your thinking. But then now let's go to the next question, because the topic is not only about the sustainable agriculture, we also have the topic about the wait. About this one. So please go to the third question, and the third question will be this. Because the topic is precision farming towards sustainable agriculture, I want to know whether you have been familiar with the precision farming concept or not, or even if you also thinking about it, you are not even interested with this topic, please just let me know also. I hope you will be interested after this one. Because BIOS Agrotechno and also other startups in Indonesia talking about this one is talking about the precision farming. So and I think it's not well, a lot of people don't know about the precision farming. I hope after this one you will have just a little bit of view about what is a precision farming. Okay, because 9 of the 9 people that is collaborating in this 10 of the 10, the collaborating in this quiz, saying that you guys are not familiar with the precision farming. So I will not continue to the next one because the next one will be asking you what do you think about the precision farming. Okay, so I hope that's a little bit warming up this classroom. So we have more excitement during this discussion. But so let me start first. So please come back to the Zoom, and then please come back to we will start our discussion. So I would like to start with this one. I think you guys already know that this fact that we are all currently facing globally the problem of this one. I don't know if this is the problem or the punish, because a lot of people also don't like to say that this is the problem, because a lot of people, at least in Indonesia or in other emerging countries, saying that we will have a burnish demography, which means that we will have a lot of people living in this world, in the same world that we are living in today. And the statistics says that the world's population will approach up to 9 billion by 2050. And this is a lot of people, right? And by this increased number of people, we know that the needs of these people is also increasing, of course. We are talking about a lot of the resources like water, like a clean water. Of course, if we want to live, we need water for drinking, for living, for hygiene, and etc. And then, of course, what we are also, what a lot of people also talking is about how we serve, or how do we provide food for us actually, because a lot of people is the growth of the people of the or the population is not as sorry, the growth of the agricultural sector is not as fast as the world's population grow. So this can be a problem, and also the production sector is very it can be very affected by this one if we don't change. So what kind of change that I am talking? So if you are familiar, I think you guys are familiar with the sustainable development goals. So it's the agenda of a lot of people. Sorry, I think all of the people that are living in this world, that we have this agenda to have these sustainable development goals, and we have 17, I guess, goals. But one of the most important one is the goal number 2, which is zero hunger, and one of the goal is to end hunger. So currently, there are, I think the data is still in 2018, but I think it's still, what we see is the trend. So from 2014 to 2018, there's an increase in the number of population that is affected by the moderate or severe food insecurity, meaning that 26% of the a lot of 26% of the total population globally is having this problem, which is the moderate and severe food insecurity. So they don't have access to nutritious foods. And so that's why, to end hunger, we need to achieve food security and improve nutrition and promote sustainable agriculture. So why is sustainable agriculture here? So talking about the severity, so this is from the Global Hunger Index, and this is the index by the severity. So it's ranging from the low problem up to the extremely alarming food or hunger problems. And as we see here, Indonesia, where I am actually at right now, it's in the serious problem of the hunger. And if we continuously having this kind of food system today, we are talking about the quantity, quality, the capacity. It can be even worse. It can be even go to the alarming, or even the extremely alarming. So in the zero hunger goal, in the sustainable development goal, one of the mission that we need to achieve is to change the global food and agriculture system. Now, talking about the sustainability, currently, all of us, I think a lot of us in Indonesia or even globally, practicing not sustainable, unsustainable agricultural practice. Just what you guys are already saying on the quest before, that a lot of waste is produced. Like we use too much, so it's not efficient, but too much agri inputs like fertilizers and then pesticides and etc. and making this land of farm and the food production sectors of farm or land unsustainable, and they are just it's just dangerous for the land. A lot of a farm that I visited few years back currently is not productive anymore. It is because of the unsustainable use of resources like water, pesticide, and etc. So we really need to change the chain and the food production system. So now talking about the resources, I told you about a lot of resources has been used in food production sector or agriculture in this case. So one of them is actually the water. So the data said that 70% of available water is used only for food production sector. So from this picture, we can learn that we all know that majority of the water in this planet Earth is salt water, which is 97% of the water that we have in this world is actually salt water that we cannot really use for agriculture, right? So 3% of them is actually fresh water. And then from these 3%, the majority of them, again, almost 70%, or to be exact, it's 69%, is actually ice caps and glaciers. That again, we cannot really use them for our activities, for domestic, for industrial, or for agriculture. So only 31% on average, the number of water that we can really utilize for our activities. And from these 30%, 10% is used for domestic use. So what is defined as domestic use is actually for your hygiene, for drinking, and etc. And then the higher number, which is 20%, is used for the industrial activities. For example, for the production, for the manufacturing, we need water for all of them. And the big chunk of this one, which is 70% of the available water, is used only for agriculture. So we know that food is very important for us. But then if the number is high, very high, 70%, if we use this only for the food production sector or agriculture, it's kind of unacceptable, if I can say, for the other sectors, because we need water for a lot of things, not only for agriculture. But we know that food production is very important because we need to eat, right? So there is a big debate on this one, on how to make this. Can we actually make this water more efficient? And it's not only for like the agriculture, as we said, like a horticulture, food, like a rice field. It's not only that, but we are also talking about the aquaculture, the animal husbandry. They also use a lot of water. That's why like an aquaculture and etc. also developing a lot of solution for this one. And if we are zooming in, so this is globally, the global number is this one. But if we are zooming into Indonesian landscape, so again, we have the potency, we have the utilizable, and then if we go to this one, the domestic and industry using only 20%, about 20% in Indonesia. Meanwhile, the agriculture, the number is even higher compared to the number of the global one, which is 80%. So again, a lot of a big debate are on this one. We know that food production sector is very important, and the water is also very important for the food production sector. But do we already use water efficiently in agriculture? That's the big question. Now we go to the fact. So this is the photo that our team is taking on Lembang. Lembang is one of the food production sector or agricultural land in West Java area in Indonesia, and only this district is supporting I think the majority of the vegetables and also food in Jakarta, which is the capital city of Indonesia, and also West Java. So this area is actually very important for food production sector in the big cities in Indonesia, in Java. And because of that one, of course, Lembang is more modern compared to the other agricultural sector or agricultural area in Indonesia. But if you see in the horticultural land in Lembang, this is the majority of what they are using. So how do they actually irrigate the farm is actually by using the hose, and they connect this one to the reservoir, for example, the pond or with the water torrents or something like that, and then they will use the machinery like a pump, or they will use the gravity to do the irrigation to the crops. This is the tomato line, by the way, and they do the irrigation one by one. And then we ask them, how do you know if the water is actually enough, or the crops is already have enough water to be irrigated? And the answer is this one. So this one is this is the real one. This is the real interview with the farmer. And this one, not everyone is like this, but this is one of the most extreme condition that we have been seeing in Lembang. Again, the more modern area of agriculture in Indonesia. And one of the farmers say to us that he used a song as an indicator. So it's normal to have like a mini radio or mini speaker that they bring from the home to the land, and they play the song, and then based on the song, if it's finished, they will move to the other land or to the other beds. And of course, it's not efficient, but well, we cannot really say that the farmer is wrong, because it's just because they don't know. It's just because of the limited knowledge of a lot of farmers in Indonesia. But it leads to unsustainability, as you say, as the wasting. It's wasting of water, of course. As you see, do we need that lot of water to really irrigate this small farm of tomato? I don't think so. So yeah, the limitation on knowledge and also technology and machinery leads us to this unsustainability of agriculture. Therefore, why we develop a technology-based solution for agriculture. So let's go to this one. So we know, let's go back to this one. So we know that from this figure, there are two very big numbers here on the left one and also the right one. On the left one, we know that 97% of the saltwater cannot be used for agriculture. So a lot of people already develop technology or develop solution for this one, which one of them is actually the process of desalination of seawater. So they try to make this big number, 97% of the sea water or salt water can be used for a lot of this one. So they want to increase this number from 3% up. So with the desalination, they will use the ocean water or sea water, and then desalinate the salt and also the minerals, and then we can produce the fresh water. But it's a very expensive process. We need a lot of investment and then a lot of energy use on this one. Therefore, a lot of people or a lot of countries actually that don't have access to capital and also access to enough energy cannot really use this solution. But this one can be used, of course, for make the agricultural water use more efficient. And we don't really disturbing this domestic and industrial sector when we are using the water for agriculture. But then the second one is how to make this number, which is 70%, is very big, right? We have already talking about this one, to more efficient consumption. So when this one is making the water reservoir is increasing, but on this one, how to make the use is more efficient, or to be simply said, how to reduce the use of water. So with the low awareness on sustainable agricultures, we cannot really say that so for this one, for example, because we have 70%. Wait a second. Okay, I'm so sorry with the technical problem that I am facing. Okay, so we cannot really say that this is the fault of the farmers, because what? Because of the farmers have been busy facing a lot of problems in the production, for example, pests and diseases, increased agricultural inputs and prices, and something like that. And also they have limited access to appropriate information, like I said to you before. So it's not completely, we cannot say that this is the farmer's fault that they're not sustainably doing the irrigation. And that therefore we need the encouragement for them, how to make this possible for them easily, and etc. So yeah, on average, farmers spend more than 5 hours a day only to do the irrigation, and this is because of the very traditional approach that I told you before. This problem is also followed by this demographical problem, that the number of the farmers in Indonesia is still decreasing in the very alarming rate currently. Meanwhile, today, majority of the active farmers is in the older age. As if you can see here in on the bar chart here, that the majority of the farmers is concentrating in the old age, which is older than 45 years old. And then from this one, we know that we have also problem in demography of the farmers in Indonesia. So what we're thinking now, so is here. The problem with the very current traditional agricultural irrigation system is it's very human dependent. You can imagine they still use the hose and do the irrigation one by one to the crops. That's very inefficient, right? But there's also a problem that the limited access to HR that I told you before, that the majority of the people is very old now, and then the number of the farmers is decreasing. So the farmers in Indonesia currently facing this problem. So that's why what we are doing now in Biosensing Agrotechno is actually how to develop something that is we can make the impact on how to use the water efficiently, like this one, without saying that this technology is only doing this for the farmers. So we make other benefit to the farmers, which is we make the with the same solution, we're also helping them to also solve this problem of the human dependency problem, limited access to HR. So what we are creating is actually we make one-stop solution to solve this problem, which is a very big problem for the farmers. But in the same time, we also bring the benefit or bring the impact to the water use in irrigation. So next part will be, so I told you before that to make this happen, we need to make more efficient consumption of the water, which is in this case is how to make more efficient irrigation. So in the more simple word, we say that what we are needed is how do we really know the amount of water by the crops, because we cannot really speak to the crops, right? We cannot really ask the tomato plant like, are you thirsty? Do you need water or something like that? We cannot really say that, right? So in the automatic irrigation system landscape, we now have two approach at least, which is the soil moisture approach and also the evapotranspiration approach. So with the soil moisture approach, it's more simple to understand, which is we sense like how much water is actually left on the soil system. So by having some kind of device, it can be a sensor or it can be like a pressure-based device. We can understand like what is the water left here on the soil. So this is with the soil moisture approach. But with the evapotranspiration, I asked Ms. Lelu before that are you guys from the life science or not? And then I think one majority of you are from the life science. So I believe that you are familiar with the evapotranspiration. So basically, we are sensing the rate of evaporation and transpiration. Meaning, evaporation and transpiration is what is the water that is go from the agricultural system, and then with this water that is leaving the system, we know that what is the water needed to be irrigated to the system. So with this to approach, a lot of startups like us and also a lot of research has been done to make this feasible. And this automatic irrigation and precision irrigation system is, of course, again towards the the precision farming and also for the more sustainable agriculture. So this is one of the example that I can find on how the soil-based automatic irrigation system is implemented on the farm. So we have the soil moisture detector here on the farm, and then from this one we know how to trigger the irrigation through this solenoid valve, for example, and we need the pump and etc. But the most important thing on this one is actually how do we know this soil moisture soil moisture on the land. So if the moisture is already on the limit or on the set limit, we will trigger the irrigation. So we will never let the land is too dry or too wet. But there's actually a very big challenge in this approach. So doing the soil moisture approach, there are at least two problems that at least we in Biops Agrotechno are facing. The first one is data uniformity. So just like this picture, you can imagine if you want to know what is the level of the moisture on the soil, we cannot only put one sensor, right? So if we put the sensor here and saying that, for example, the moisture is like 70%, we cannot really say that 200 meters from this one or 20 meters from this one, the moisture is the same. It's because of a lot of things can be affect the uniformity. For example, like the level of the farm. If this one is higher, then meaning that the water will go to this one. So this can be more dry compared to this one. The other thing that can be the challenge that we are also facing on the development of the technology is data validity. So because of the sensors that we are using is actually always the digital sensors. So we have the sensitivity of the sensors through the minerals and acidity. So what we have been trying using the sensors is the data is very fluctuative. And this is because of a lot of minerals are affecting the reading of the sensors and also the acidity, of course. So from these challenges, and we are still finding the sensors that can be applicable in the agricultural sector in Indonesia, but it's still on development. But while doing that, currently we are doing more on the evapotranspiration approach. Meaning that we actually having, so thank you to the science, thank you all for all the researchers that have been doing a lot of the research on evapotranspiration. So currently we can implement the evapotranspiration rate calculation on how to develop the technology based on this. So we make sure that the evapotranspiration is based on the a lot of things like temperature, humidity, light intensity, and etc. And of course, we also have the database of hundreds of crops, so we know that the calculation is specific to the crops and the age of the crops. Okay, so what we are developing is actually this one. So maybe you are already familiar with the IoT solution. So basically what we are developing is actually in commotion. It's a machine-to-machine IoT solution that enables us to do the irrigation precisely and also automatically. So yeah, I'm so sorry if I'm sharing more on more like a technicalities or more like the product. It's because I hope that I can share to you more like on more like a practical aspect compared to the more theoretical one. But yeah, with the commotion, we have this sensor. So what we are having is actually sensors that sensing several data like temperature, light intensity, humidity, rain intensity, wind speed, wind direction, and etc. So it's just like a normal weather station, but the difference is we don't send this raw data to the farmers. It's because of course the farmers don't have enough or appropriate knowledge on utilizing this kind of data. So instead of sharing this raw data, we share this data, or sorry, we send this data to our system where we have the algorithm working on calculating the evapotranspiration, and then from that we know how much water is actually needed by the crops, and then we trigger the automatic irrigation, just like the what I previously shared, and the irrigation will be done automatically. So with this one, we do the irrigate. We help the farmers to solve the problem of the limited access to people that is working, because this is actually automatic, so they can focus on doing other things like harvesting or doing the pest controls, doing the pesticide spraying and etc. While the irrigation, which takes 5 hours a day, has been done automatically by this one. So what they are seeing is they have this benefit for them. They can save the time, but in the same time, with this commotion, we can help the sector to actually save the water, because what we are irrigating to the farm is actually the right number, like the number that is actually needed by the crops. So we have the precise irrigation system. Okay, so next, Yeah, this is one of the case study that I can share today. So this is in the bell pepper farming. So what we have been doing with a farmer in West Java area is actually doing a research. So we have been doing this research in bamboo screen house, so we can eliminate other aspects like raining and etc., because we want to compare these two methods. So in this bamboo screen house, we divide the screen house into two parts. The first part is using our encomotion system and helped by the drip irrigation system, and the other half is using the manual irrigation. Talking with the manual one is actually the same one that I told you in the beginning, which is using the hose and using the small pump, and then they do the irrigation one by one with the filling. So if they feel it's enough, it's enough. But if not, they still put more water and more. So the key points to analyze is actually the production or the yield. So we compare what is the production from these two methods, and then we also compare the quality of the products, because the bell pepper is one of the variety in the Indonesia that already using the grading system. So they grade very good, like they have a grade, the super grade with A, B, C, and then the rest is the very bad one. The next one is the operation efficiency compared from these two. So we analyze, can they save the money? Can they save the energy from the irrigation? What is the impact on having the automatic irrigation? And last but not least is the water needs. And the result is this one. So collaborating with the farmer, which is Richie, his name is Richie. The first thing that we believe can be helped by automatic or with the precision irrigation system is actually the impact number 2, which is operational effort cutting or operational efficiency increase. And by this research, we can show that the efficiency increased by 50%, meaning that with the same number of worker on the field, they can have twice the productivity in the term of the using of the effort. So usually they first have to do the irrigation, and then after that they do the harvesting and other things to do on the farm. But with this one, we can cut the energy, we can cut the effort, and of course, on the long run, we can save the money. They can save the money by having the automated irrigation system. But then with this research, we are very happy that actually by using the precision farming or precision irrigation, we can increase the yield of the farm by 40%, meaning that so I told you, right, we divide into two. First one is using the incommotion and also the drip irrigation, and the second one is the normal one that they are usually using. And the yield is higher by 40% on the part of when we are using incommotion, and we are very happy for that one. So we can share the benefit that is really felt by the farmers from two aspects, which is the productivity and also the operational efficiency. But then now talking more about the sustainability, which a lot of farmers is not really giving attention on this one, but with giving this benefit to them, we can also bring the impact, the environmental impact, which is we can save the water, because actually we use 40% less of water compared to the traditional way of doing the fertigation by them. So from the research, we are developing more impacts. Currently, just a little bit of just sharing that currently we have been in 20+ locations all across Indonesia, and we have been working together with a lot of farmers and farming groups. Okay, so that's about what we are doing currently. But actually, that's a very small thing in the precision agricultural world that we have been doing, because we only say about the irrigation, right? So currently, we are more focusing on how do we save the water, how do we make the use of water more efficient compared to the previous one. But because the title of this lecture is actually more general, which is more on the aspect of precision farming. So let me share to you more about other solution on precision farming. I think I have the video here. Okay, so please watch the video first about the. Wait, I think I haven't shared the sound. Oh, it's okay.
With precision agriculture, farmers need to know precisely what inputs are needed where, in what amount, and when. This requires collecting a lot of information from different sources and in different parts of the field on things like soil nutrients, the presence of pests and weeds, the level of greenness of the plants, inputs applied, and the weather forecast. Once collected, this information needs to be analyzed to produce agronomic recommendations. For instance, given the developmental stage of a plant, its level of greenness may reveal its nutritional needs. This information, combined with the characteristics of the soil where the plant is located and a forecast of the weather, can be used to determine how much of a certain fertilizer should be applied to that plant the next day. Delivering agronomic recommendations on time to farmers, ensuring they are able to apply these recommendations is key. Farmers need to have all the necessary inputs at hand and be able to translate the recommendations into actions in the field. To solve this problem, big farmers use sophisticated machinery that collects georeferenced information on soil characteristics, yields, and greenness of the plants. These machines are often connected to the internet and send the information automatically to ag big data firms that analyze the information and send agronomic instructions back to the machines, which are able to automatically apply them in the field. For instance, using robotic devices attached to GPS-guided tractors. However, solutions like these may be economically infeasible for medium and small-scale farmers. These farmers lack the scale to afford that sophisticated machinery, lack the knowledge to operate the non-automatic aspects of the machines, and lack the resources to hire a person who knows how to do it. Sometimes, many of the necessary complements are not readily available, or there is no connection to the internet, or there are not sufficient skilled workers. However, a number of solutions are being developed to many of the problems that medium and small-scale farmers face when trying to implement precision agriculture technologies. Easy-to-operate economic sensors to measure soil humidity, salinity, and nutrient content. Portable networks to transmit the data collected by field sensors to a central location, as well as economic ways to connect to the internet. Remote sensing through the use of satellite imagery to assess the health status of plants in an economic way, and without requiring that producers know how to operate a device or interpret complex data. The new sharing economy is creating opportunities for farmers to just pay for the services they need, whenever they need them, very similar to the way that Uber operates. And there are many firms competing to provide other services such as drones, data analytics, and forecasting. All of these technological developments are pieces of a puzzle that needs to be put together to make precision agriculture a real option for medium and small-scale producers.
Okay, so that's some of the examples and also some of the fact that actually precision agriculture is a big term. So we are not talking only about one aspect of what is it, the agricultural agricultural. Sorry, share first. Okay, so it's not only one agricultural activity, so it's not only irrigation, but we have a lot of activities in the agricultural sectors, like so irrigation, and also doing the spraying, and also giving the fertilizer, and etc. So there are a lot of challenge of precision farming, and it's also already been saying on the video that I've showed you before. So first one, there are the practicalities problem that we are facing. First of all, a knowledge barrier. Again, it's not the fault of the farmers. Of course, it's never the fault of the farmers. It's just how we as the developer or researcher, I believe that a lot of you guys want to be a researcher. Maybe I hope one of you also will join us in the journey to also doing things on precision farming. The big challenge is how do we make something that is really easy to use, really simple to use for the farmers. The thing is, in Indonesia, a lot of the farmers is actually not having a lot of knowledge on a lot of things that we have been researching on the university. So knowledge barrier is actually a very big problem here in Indonesia. Oh, well, I guess not only in Indonesia, but yeah, unfortunately, farmers or farming industries is not the thing that very induced by the education. That's very unfortunate. So that's why this also the way why we in Biops Agrotechno are developing the things that is very automatic. It's not we want to make it very sophisticated. We want to make it very cool or something like that. It's more like we want to make the thing that is very easy to use by the users. In this case, is the smallholder farmers. So you can imagine if, for example, if I can go here again, the solution that we develop is actually giving this raw data, like this temperature, light, humidity, wind, rain intensity, to the smartphone or to the phone or through the email, for example, of the farmers. And we hope that they can understand what they need to do based on this data. I don't think this will gonna happen. That's the problem of developing technology in this sector. Maybe if we talk about the education technology or something like that, it's very easy because the user is tech savvy. However, in this one, we cannot just develop the technology just like that one. So instead of this one, we need more knowledge on our side on how to make this data more valuable for the users. So on our case, we develop we develop the algorithm, and the algorithm is science-based actually. So it's calculate how to calculate the water that is needed by the crops and from evapotranspiration. So this is our task, that we are learning science, we are learning digital. So the thing that we need to have on our solution is actually, is it really easy to use by the users, in this case the farmers. So first is that's the knowledge barrier. Secondly, we have the limited infrastructure. So talking about technology is maybe too far. First of all, mechanization in agriculture, for example. We talk about the tractors, we talk about the water pump, which us in this room are maybe saying that that's a very simple technology, that's a very simple machinery, but the infrastructure is very limited actually. So in our case, we are developing IoT, meaning the Internet of Things, that we of course need internet. We of course need some sort of energy on the farm. So that's not the case. That's not always the case on the agricultural land in Indonesia. A lot of part in Indonesia that I've been visiting does not have good connectivity like the internet connection, etc. But on the other hand, we also have, I think a few months ago, I went with the KZ together to Wakatobi. It's in Southeast Sulawesi. We went there in one of the island of Wakatobi, which is Kaledupa. So Wakatobi is Wangi-Wangi, Kaledupa. I forgot the other two islands. And this island it's not 24-hour electrified. So it's only 12-hour electrified, which is on the night. But then on the afternoon, of course, we need electricity for doing the agriculture activities, because the agriculture activities we will do it on the noon, in the morning until evening. So this can be a very big challenge for the precision farming concept. So how do we actually face this challenge? So we do a lot of collaboration on how to make this happen on some of part of the Indonesia. So for example, in the Kaledupa, as I told you, we actually working together with the developer of solar panel. So we make the solar powered pump. So actually the pump that can circulate the water that's for the irrigation for our system is from the solar energy. So if you want to develop this kind of a precision farming concept, please make sure that they also thinking about the risk of infrastructure. Thirdly, there are too much problems to be solved. It is because of the induction of the technology and scientific-based solution in agriculture is quite late. Therefore, the problem is already piling up. It's already a lot of problems in on the farm. That is why we in Biops Agrotechno have been sparing few years only to develop the solution only for the irrigation. So for this one, we believe that collaboration will be the key. That we in Biops Agrotechno are currently having the solution for irrigation, but the other startup, for example, are focusing on the more precision pest and disease controls. So we can collaborate together to make this happen for a lot of problems of the farming in Indonesia. And last but not least is talking about the skill regarding the practicalities. If you maybe don't know the agricultural landscape in Indonesia, so the farm owners in Indonesia only have on average 2,000 square meters to 5,000 square meters per person. So it's very small compared to, for example, in the US, a lot of food production sector is actually farming companies, which has like few hectares in one area. So the scale can be a problem here, because we are talking about the capital, right? We're talking about the investment. If the location is scattered and it's too small, a lot of solution cannot really be implemented on this kind of this kind of a sector in Indonesia. So we always need to think about the scale. So regarding the practicalities, I also want to share with you one of our close friend. The founder of the startup is also from the School of Science and Technology. That's also working with the precision farming for plant and diseases. It's called Neura Farm. They can scan the pests and diseases, or the diseases that has been happened on the plants, and they can give the recommendation to the farmers to the recommendation of like what kind of pesticides is actually needed for this kind of problem. So I don't have the video of that one, but I have a similar one. So this is also one of the example of precision pest and diseases control. Okay. Okay, so that's the other example of precision agriculture and how it is implemented in the field. Okay, so let's go to the next problem. So we have been talking about the practicalities. It's starting from the knowledge barrier, infrastructure, too much problems, and also the skill. Just like in the video that it is showing that using the satellite data is actually now it's very cheap if we can use it very good. However, talking about the scale, currently we cannot really use this for the agriculture, but we can use it for like a more so for bigger agriculture or even in the forestry. So it has been done now, but for the small agriculture or horticulture, we still need to develop things. So we need time, but yeah, I think in the near future we can also make it more applicable, especially in Indonesia. So secondly, what is very important that we need to make a point is actually the business model. So I think in the second video, I mean in the previous two videos, it's also said that the business model is always the problem here. The problem is something like this. Can you imagine that you are a farmer, you are a traditional farmer, for example, you are used to when you're spending the money in the traditional agricultural system, you don't used to giving the money for the investment capital. So they like to give the money to the workers every day. So it's actually a daily span of money. But with the precision farming, we need to do some kind of capital, because you need to install the device, we need to install the machinery, we need to install the infrastructure. So that's always also the problem in the precision farming. That is why the precision farming is not really widely implemented, especially in Indonesia. So that's why when in our case in Bios Agrotechno, we currently having several business model. So it's not only they can buy, but they also can rent our device. So a lot of developers in this sector is actually managing the subscription model instead of the capital or the investment capital model. So it's more suitable for the users. And last but not least, long research and development. We know that the science-based industries or science-based solution need time to develop. And in life science, I think it's even worse. Why? It's because of we are talking with the living organism. So, for example, when we develop something, we need to see the impact after. For example, if we're talking about a tomato, after the tomato producing the fruits and it's ripening and then it's harvesting, and it takes like 5 to 6 months, I think even more, to only have one data. So it needs long research and development. So that's why I think it's also what makes the implementation of precision farming in agricultural sector, especially again in Indonesia, is very slow, the implementation. So for us who want to develop this kind of things, we need to be patient. We need to have a lot of perseverance to make this happen. Seeing that after we do all the research on the science part, we also need to develop the business model and the practicalities. But even although this is very hard for us to develop this kind of thing, wait a minute. I'm so sorry with the practicalities. I don't know what's the problem with this one. Please bear with me. Okay. So yeah, what we have always believed that developing this kind of solution is it needs time. It's still a long way to make this like a complete solution for the agricultural sector. But we always believe, at least me personally, I have this one, the best time to plant tree was 20 years ago. The second best time is now. Although maybe a lot of people already thinking that it's too late. It will after we finish the research, it's already like a lot of problem will already coming again and again and again. A new problem will coming, but the second best time is now. If we are not doing that, it will never happen. So if you have this passion, I would like to invite you to always join us in or without Bios Agrotechno to together develop this kind of things to bring the new year of agriculture in Indonesia. So I think it's already 1.5 hours of me sharing something and you hearing about me, and bear with me with all the technical problem. I'm so sorry. But now I think time for discussion. So if you have question, let's have a good discussion after this. Thank you so much. Back to Miss Lily.